One day, vast grasslands started to open. Clouds of volcanic gas and ash rose into the sky. Flows of lava streamed down the hills and across the plains. Within minutes, black volcanic glass started to rain from above, wiping out animals, crushing plants. It didn't take long before the land caved in, opening giant pits filled with red-hot magma. Not so long ago, there have been some curious changes in water levels in different parts of Yellowstone Lake. The water level could be rising on one side of the lake and falling on the other at the same time. It looked as if the lake basin was getting lifted by some underground forces. Is it a sign of a looming disaster? Is the Yellowstone supervolcano ready to erupt? Let's figure it out. Geysers, mud pots, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Such volcanoes produce super eruptions. When it happens, about 240 cubic miles of ash, molten rock, and hot gases get launched up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through the Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe that they had been created by many weak eruptions. But after doing some more research, experts found out that these deposits could have been left by a previously unknown super eruption that took place about 8.7 million years ago. A year before that event, Yellowstone gave a warning. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression released gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging that area. Experts think it was the greatest eruption of the Yellowstone supervolcano. This giant, which is actually one of the largest active volcanic systems on our planet, wasn't named supervolcano for nothing. There have been at least 3 other super eruptions in the history of the Yellowstone volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago. They were 6,000, 700, and 2,500 times more powerful than the devastating eruption of Mount St. Helens in Washington state in 1980. The most recent super eruption was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out 240 cubic miles of rock, dust, and volcanic ash. By the way, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out so much boiling lava, it would be enough to fill Sydney Harbor 4,500 times. Scientists believe that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down. But back to the main question. Are we about to face another super eruption in the nearest future? It would be a catastrophic event. A massive column of lava and ash would rise into the air up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. Such a mixture of lava, ash, and gas would be immensely hot. Moreover, it would also move around at a speed of 300 miles per hour. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. When the ash got into the stratosphere, the temperatures all over the world would drop. In the worst-case scenario, the eruption would be very rich in sulfur. And since this substance is an effective sunblocker, the temperatures would get so low that there would be no summer in the world for the next several years. The seasons would change. Agriculture would face serious problems. The disaster would create disruptions in food supplies. The Federal Emergency Management Agency has estimated that the potential damage would make about $3 trillion in the US alone. But the good news is that scientists think that the Yellowstone supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Which means that the probability of the eruption is 1 in 730,000. This probably is almost the same as the probability of a big asteroid crashing into Earth. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the unusual activity going on there. Still, there have been tons of discussions about what people could do to prevent the disastrous super-eruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat coming from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano will erupt. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6-mile deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very nice. About 10 cents per kilowatt hour. Sounds like a great plan. Are there any drawbacks? Unfortunately, yeah. Let's say you're drilling a well to deliver cold water to the volcano. And then you accidentally hit its magma chamber. In this case, instead of cooling the giant down, you make the top of the magma chamber much more fragile than it used to be. And the whole construction will be at risk of collapsing at any moment. And don't forget that this drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Or imagine drilling through Earth's crust, getting deeper and deeper. And then, wham, bam! You hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful blasts. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. But the worst thing? The project would last for thousands of years, up to 16,000. The problem is that by using this method, you can't cool the volcano faster than at a rate of 3 feet a year. On top of that, scientists aren't 100% sure that when they finish this project, the volcano will stay cold for at least 100 years. Yellowstone isn't the only supervolcano on Earth. Check out the list. It includes the Long Valley Caldera in California, the Etana Ignimbrite in Chile, Toba in Indonesia, Taupo in New Zealand, and so on. It's official. We now know the exact location and timing of the Yellowstone supervolcano's next eruption, and it's called a supervolcano for a reason. It will be thousands of times more powerful than a typical volcanic eruption. When this happens, the planet will face massive disasters. Earthquakes, tons of magma flows, ash and clouds that will block out the sun. The sky will be gray for a long time. We will have a shortage of food because of the lack of sunlight. Planes won't be able to fly. Some species of animals and trees may disappear. One disaster will follow another, like falling dominoes, one by one. Terrible times await Earth, and okay, stop. It's clear we got it. But when will all this happen? Don't worry, you won't be left without an answer. When ordinary volcanoes erupt, it's always a disaster, but only for those places that are located near the epicenter. Multiply the damage from an ordinary volcano by thousands and you'll get a supervolcano eruption. Yellowstone is one of the largest volcanic systems in the world. It's erupted 3 times in the last 2.1 million years. The last time was 640,000 years ago. The ash covered an area comparable to about half of the United States. Fortunately, there were no people there, but nature got hurt. A similar eruption of a similar supervolcano occurred about 74,000 years ago. It was the Toba supervolcano in Indonesia that caused an apocalypse the human race barely managed to survive. According to some theories, only a few thousand people stayed alive at the time during the volcanic winter, but it's not confirmed. Since Yellowstone is a volcanic system located in a vast national park, it was important for scientists to find out exactly where the first spark would come from. They found out that Yellowstone's magma doesn't accumulate in one place, but hides in several separate underground reservoirs. The reservoir in the northeast of Yellowstone, next to a beautiful place called Sour Creek Dome, is the riskiest. Here, the red-hot magma comes into contact with the hot rocks of the mantle, which are located deep in the ground. Their high temperature keeps the magma in a liquid state. Imagine that you put a pot of hot milk on the stove. Nothing cools down, but only gets hotter, so the milk may soon begin to rise and flow out of the pan. The same thing is happening with the magma under Sour Creek Dome. Magma doesn't cool down there, and at some point it may start to come out. It'll be like a broken pipe from which a fountain of boiling water gushes. But how did scientists find out? The magma reservoirs are located at a depth of about 6 miles, and this whole area is incredibly hot. They used a special method called magnetotellurics. So, Earth's rotating core creates a magnetic field that surrounds our planet. Magma flows around the core, and it contains many magnetic minerals that also create magnetic fields. Scientists use special instruments that sense those fields emanating from the magma, like a metal detector senses lost jewelry on the beach. Using magnetotellurics, they scanned Yellowstone and discovered 4 large magma reservoirs. 3 of them emitted powerful electromagnetic waves, and in the 4th, which is in the northeast, they recorded a much stronger signal from the magnetic field. This is where the eruption is supposed to occur. But fortunately, it won't happen soon. Perhaps in tens of thousands of years, perhaps in hundreds. Phew, you can relax. No volcanic apocalypse is coming soon. But how do scientists know when this magma will start to erupt? Magma doesn't have a timer, and the volcano doesn't wake up with an alarm clock. So, magma flows inside the pores of solid rock. It resembles a dishwashing sponge with lots of small holes through which water passes. Magma penetrates these pores and fills them. For magma to start erupting outward, it must fill at least 40% of these pores. About 20% of them are filled now. But these hot rocks continue to heat the magma and keep it liquid, so it can flow between the pores. At some point, it will connect with other pools of the liquid magma and become a large stream that will rise to the top. How can we prevent this from happening? It seems that the solution here is to cool the balsam rocks, but it's impossible to do so. They are several miles deep, they are incandescent, and there are too many of them. And in any case, trying to cool a part of the Earth's core sounds like a very bad idea. All we can do is accept that nature has its own plans. If the eruption occurs in tens or hundreds of thousands of years, then perhaps humanity will find a way to solve this problem. If not, then we should prepare for the consequences. A huge global catastrophe starts with a massive, large-scale explosion. The erupting magma produces a gigantic amount of ash. A powerful burst of energy collapses the Earth's crust over the magma reservoir. This leads to the formation of a giant caldera. You've probably seen a huge crater in a volcano. So, this is the caldera. The natural disaster is so loud it deafens everyone who's nearby. The blast wave rises ash and pumice stone at a speed exceeding the speed of sound. Volcanic materials reach incredibly high altitudes in minutes. Then, this pillar of ash spreads and plunges a huge territory into darkness. The incandescent particles in the lower part fall under their own weight and heat the air around them. It's almost impossible to breathe. The red-hot pieces of pumice stone and ash set fire to the surroundings. All this hot mass turns into pyroclastic flows that destroy and burn everything in their path. Forests, houses, roads, everything turns into coal. No planes can fly there. Tiny particles can penetrate engines. Besides, it's impossible to see through such a dark gray hot cloud. It's also dangerous to drive cars. Volcanic particles can burn tires. Luckily, thanks to seismic technologies, people have learned in advance about the eruption, so everybody has evacuated. The column of ash that has reached the edge of space continues to expand in different directions. The wind helps the volcanic dust expand. A giant umbrella-like cloud appears over the territory of Yellowstone. It's getting wider and wider and plunges a huge area into hot darkness. During the first 24 hours, ash falls on most of the United States and parts of Canada. It knocks out power lines, pollutes bodies of water, and destroys crops. Then, the rains begin. The water mixes with the ash and falls to the ground in the form of gray mud. And don't forget, it's also poisonous. The ash contains mercury, arsenic, and lead in large quantities. Such toxic masses poison rivers, lakes, land, and air. All this time, the volcano continues to erupt. The outbursts of magma, ash, and pumice can last for several weeks or even a month. And this is just the beginning. The ash soon begins to settle, but the sulfur dioxide released during the eruption spreads all over the atmosphere. This gas mixes with the atmospheric water vapor and forms an aerosol consisting of small particles. All this covers the planet like a veil. This cap makes it difficult for the sun's rays to pass through, which means it lowers the temperature of the Earth's surface. These events cause a sharp cooling of several degrees in the world. Farmers lose a huge amount of their crops. Food prices rise and economies collapse. There might be a famine all over the planet. Human civilization can plunge into chaos. In a few years, the temperature will start rising, but it will take at least a couple of decades to return to previous standards. What will become of humanity by that time? Of course, we will survive, but we'll have to rebuild our civilization. But don't be afraid. If nothing depends on us, let's just enjoy every day of life. Be grateful and help each other. Supporting and caring for each other even during the volcanic winter is a guarantee that humanity will survive.
So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Microbial claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Poland and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate.
It happened around 8.7 million years ago. All of a sudden, vast grasslands started to open. Clouds of volcanic gas and ash covered the sky. Flows of lava streamed down the hills and across the plains. Within minutes, black volcanic glass started to rain from above, wiping out animals, crushing plants. It didn't take long before the land caved in, opening giant pits filled with red-hot magma. It was the greatest eruption of the Yellowstone supervolcano. This giant, which is actually one of the largest active volcanic systems on the planet, wasn't named Supervolcano for nothing. Spreading deep underground and extending for hundreds of miles, supervolcanoes are complicated structures. Experts are still unsure what processes can trigger these fire-breathing monsters and lead to super eruptions. When it happens, more than 240 cubic miles of ash, molten rock, and hot gases get hurled up into the air. 4 super eruptions would be enough to fill the Grand Canyon to the brim. Volcanoes create mountains, but supervolcanoes wipe them off the face of the earth. They change climates and ecosystems. Thankfully, these disastrous events don't happen more often than every 50,000 years or so. Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground and burst through the Earth's surface. Usually, all this magma gets stuck, unable to break through the planet's crust. Large pools of pressurized bubbling magma gather at a depth of several miles. The pressure keeps growing since more and more magma is trying to get to the surface. And then, wham, bam, a super eruption goes off. All those millions of years ago, the first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust, leaving behind huge chambers. Those were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding after more and more magma arrived with time. The land over the volcanic system was inching upward, slowly, almost unnoticeably. A year before the super eruption, Yellowstone gave a warning. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression released gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle with soda after you've shaken it. Something like that was happening near the volcano. The pressure was released through the fractures when gases were bursting out from under the surface. Right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe, but the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurtled up into the air to a height of over 16 miles. Within several minutes, a pyroclastic flow rushed across the area at a phenomenal hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With the temperature of more than 1,300 degrees Fahrenheit, it was burning everything in its path. The volcano kept pumping ash for days on end. The air in that area heated up to 570 degrees Fahrenheit. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds after being inhaled and getting in the lungs. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a 10-feet layer of ash covered the territory of about 50 miles around the center of the eruption. In the end, tiny particles of volcanic ash coated almost all the western part of North America. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. The monsoon seasons changed. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It covered more than 8,900 square miles of what's now southern Idaho and northern Nevada. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. There have been at least 3 other supereruptions in the history of the Yellowstone volcano. They happened 2.1 million, 1.3 million, and 64,000 years ago. They were 6,000, 700, and 2,500 times more powerful than the devastating eruption of Mount St. Helens in Washington state in 1980. The most recent supereruption was dubbed the Lava Creek Eruption. It formed the Yellowstone caldera after spewing out 240 cubic miles of rock, dust, and volcanic ash. These days, Yellowstone National Park is a mind-boggling collection of 10,000 mud pots, hot springs, geysers, and vents emitting volcanic gases. Heat-loving microorganisms live in most of them. They paint the park in its brilliant colors. The most famous geyser is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than others, erupting about 17 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach the height of 180 feet. Scientists have spent many years trying to figure out what's hiding under Yellowstone Park. They've discovered that surface water goes several miles down into the crust. It gets heated and boils, supplying the geysers. Around 7 miles below the surface, there's a reservoir of half-melted rock. That's the magma chamber, and it's more than 30 miles wide. An enormous plume of hot rock, which looks somewhat like a mushroom, feeds this chamber. It rises from the depth of 400 miles, traveling through the planet's upper mantle, a thick layer of mostly solid rock. Sometimes, this plume overheats the magma chamber. The land in that place lifts, and tiny earthquakes help some liquid escape to the surface. The pressure inside the chamber drops, and the ground lowers again. Since 2004, some parts of the Yellowstone caldera, which is a clever word for a volcanic crater, have been surging upward much faster than usual. The rate's been almost 3 inches per year. No uplift has been that quick since scientists started close observations in the 1970s. And still, experts are sure the supervolcano doesn't present any danger these days. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even if there's some volcanic activity, it's more likely to be a spurt of oozing molten rock, known as a lava flow. It does present some danger, but it's easily avoidable. Or it can be a hydrothermal explosion. Then, a large volume of superheated water trapped below the surface will rapidly turn from liquid into steam. This steam, along with boiling water, mud, and pieces of rock, will burst through the surface with great force. Then, the debris will litter the area of up to several miles in diameter.
We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hotspot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called mushroom pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned. So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud ponds, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down. Or, just maybe, one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea. But sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be. And the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well, there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight.